Hello. So in week 2, we're going to continue working in Python, and we're going to talk some about the logical operators and how you can write conditional statements. And it's going to be a really fun week because now we can go through and start making programs kind of feel like they are making decisions themselves. So we can make programs go through and do different things based on the user input that we might get in from them. And it just makes what we are able to do a little bit more interesting. So, okay, the first thing to go through and talk about for this is Boolean expressions. And I mentioned the bool data type last week. Bool is going to be something that can store a true or a false. And in the computer, we're going to store that as a true would be a 1 and a false would be a 0. So what do I mean by something that can evaluate to true or false? We will have kind of like an entire test, an entire like conditional, and the whole thing can be simplified down to either a true or false value. So some examples. Maybe we go through and look at relational operators. So, kind of just based on the name here, a relational operator is going to be comparing how two different values relate to each other. So, for example, go ahead and test, is this value equal to this value? If it is true, return true. If it is false, return false. So that whole entire thing can kind of evaluate down to a true or false value. In computer science, this exclamation mark very often means not. So two equal signs are going to check for equality. Are these two things equal to each other? And then an exclamation mark with an equal sign says not equal to. So I would be checking to see, are these values not equal? Less than and greater than work the same way that they always have in math. But my less than or equal to and my greater than or equal to have to look a little bit different. You know, when we write that in math, we usually kind of write like the symbol and then we put the line underneath it to represent or equal to. My problem with doing this in programming is that I don't have a key on the keyboard that has, a less than or greater than with a line under it. So what we do in computer science is we just write our less than, greater than symbol, and then we put the equal sign right after it. Okay. So let's just kind of take a look at some of those examples. So let's say I was going to ask the computer, print out, does 4 equal 4? Yes or no? And so that evaluates to a true or false, and it's just going to print out that result. Notice that in Python, we do use a capital T and a capital F. That's different than most other languages. If you've worked in Java or C++, you're probably used to that being lowercase. But in Python, we are going to capitalize it. I could also ask it to do some sort of mathematical expression. Like I could say, is 4 equal to 2 plus 2? So, go ahead and do this operation, check to see, is this value equivalent to this value? And, yes, it is. 4 is equal to 4, so it still equals true. Let's do an example of a not equals. So 5 does not equal 4. And you'll notice that Code Mirror, which is handling some of our, like it's doing some of our interpretations of our Python code, it went ahead and kind of changed the way this symbol looks. It's nice because it's really clear that this is representing not equal to, but I do not like that this is not showing you an example of how like the program, like the code actually looks. So why don't we go ahead and just add a comment to ourselves that what, even in the comment it updates it, that the way I'm actually writing this is with a not equal to. Okay. So 5 is not equal to 4. That is a true statement. 5 is not equal to 5. Well, that's false. 5 is equal to 5. Okay. We can also have logical operators. So relational operators say, take these two different values. So my two operands, I have one on the left, I have one on the right. I say, take these two different values and compare them to each other. How do they relate to each other? A logical operator is going to allow us to go through and say, I want you to take these two expressions on the left and on the right, and I want to know how they relate to each other. But instead of them being numbers, instead of them being numerical values that I'm going to compare, like equal to, not equal to, less than, greater than, things like that, my logical operators are going to be used to say, how do these two true false values relate to each other? How can I go through and combine two Boolean values? So we have three of them. We have and, or, and not, and they behave exactly the same way that they behave in English. So when somebody says and, what has to be true for and to be true? Both of those things have to be true, right? If you're a little kid and your mom says you can have a friend spend the night this weekend, if your room is clean and you are passing all of your classes and you go clean your room, but you are failing Spanish, you're not going to have a friend spend the night, right? Because they have to both be true for and to be true. The or operator, you only have to have one. You can have both, and that's great, but you have to have at least one for the entire thing to evaluate to true. So the example I kind of give for this in class is there are two different ways that you can have money. You either have money because you were born wealthy, so your parents are rich, and so you have money just from inheriting it, family money, or you have money because you earned it yourself. So either you have a high paying job, or you won the lottery or something like that. You made your own money. And so, as long as one of those is true, the whole thing is true. They can both be true. You can just be like super rich, right? But you need at least one. And then what not does is not not does not work the same way as and or. And or, you have to have two operands on both sides. And my question is like, how can they both be joined together? Not is only applied to one operand. So it just takes one single input and all it does is just negate it. And that is just the same way that it is when we are using a sentence. The word not just says, I want you to do the opposite or take the opposite of whatever this says, right? So not true, you just make it false. Not false, you just make it true. So here are some examples of running that in that glide editor. So I could create some variables, and these would be bool variables. We call them Boolean because they are named after George Boolean, the mathematician who kind of came up with these logical rules. So if I said, what is A and B? So this would be false because they are not both true, right? You cleaned your room, but you are not passing all of your classes. That is false. You do not get to have a friend over. And then in this example, it's an or. So that's fine. You are rich as long as one of those two things are true, right? If you are Bill Gates's daughter, but your job is just like sharpening crayons and you don't make any money, that's fine. You still have money because this was true and you just inherited it, right? So one thing that is nice about Python that makes it very easy to read is that the and or, and not operators are literally just the words spelled out. And in a lot of other languages, these are actual kind of operator commands. Like we'll put an ampersand, or we'll put bars or exclamation marks or something to sort of indicate these. And you have to go through and memorize those operators and what they are. In Python, you can just write out the word. So that's really nice. The logical operators are short circuited. And what that means is if you do the left-hand side and you already know the answer, the computer is not even going to go through and calculate the right-hand side because there is no point. It doesn't need, like, don't ask it to go do work that is unnecessary, right? If I said false and anything, you already know what the answer is. It doesn't matter what B equals because false and true, it's false. False and false, it's false. No matter what, if the very first thing that I tell you is false and you have an and operator, you're done. You don't even need to go over and check what's on the right because you already know the answer. Similarly, if I said true or anything is true, right? True or true, we're good. True or false, we're still good. So those kind of short-circuited rules can be very useful. We can take advantage of those. Let's say, for example, we needed to divide something by user input. So I'm going to, like, I mean, this is just a silly little example, but let's just say that for whatever reason, we have some variable and we are going to divide by that variable. If it just so happened that that value was 0, like if I asked the user for input and they, either didn't give it to me, it didn't read incorrectly, they entered a 0, whatever. If we try to divide by 0 here, our entire computer is going to crash. We would, like our entire program would crash. We would get a runtime error because you can't divide by 0. That's mathematically impossible. And so if you ask the computer to go do an impossible task, it's just going to shut your program down. It can't follow that instruction. So one possible way that we could avoid that is we could tell the computer, I want you to check this expression over here on the left, and then I want you to go check the thing that I actually wanted to know over here on the right. So my question is, does this value that they entered, does it equal 0? Okay, because if they entered a 0 and this becomes false, then false and anything, I already know the answer is false. I'm not going to do this operation, which means I am not going to attempt an invalid, I'm not going to try to divide by 0 and I'm not going to crash my program out. The logic for it is a little bit inverted. And so sometimes that's kind of hard to wrap your mind around, right? Because I'm trying to say what over here would give me a false value. The false and anything is what would cut out. So I can't say, does num1 equal 0? Because if num1 equals 0, if that were true, I don't want to keep going. So I need to invert that. I need to say if num1 does not equal 0, then you're safe. You can go ahead and divide, do whatever you wanted to do, and actually find your result in your calculation. Okay, so let's just check a couple of examples. Let's just run a few examples using some of those logical statements before we move on. So I do have some of those logical operators. So here's that example. I'm going to clear everything out. So true and false is false, but let's just go through and see all of the examples. So we're just going to make like a little truth table here. So what if, oh, that's not what I wanted to do. I know what I want to do. I know what I want to do. I want to just take this whole thing and I want to run it with different values for A and B. So we'll make like a little truth table. So a truth table just kind of says for all possible inputs, what is the result? So if I have two inputs, I have A and B, I can have four possible combinations of all values that I could give them for true, false values. So I could have true, true. I could have true, false. I could have false, true. And I could have false, false. Those are all four possible combinations for an and statement. And if we just kind of like pause the video and just see if you can predict, if you just kind of already know what the outputs would be for these different combinations before I hit run and you see the answers. So for and to be true, they have to both be true. So this very first one is true, but everything else is false, right? You cleaned your room, but you're failing a class, no go. Your room is a mess, but you passed everything, no go. Your room is a mess and you are failing, definitely not having a friend over, right? So we can see those. And then if you went through and just sort of changed these to or statements, we could do that same little truth table for the or operator. And again, try to see if you can predict if you already know what the output would be. Or stays pretty happy, right? Or is pretty easy to please. As long as one is true, the whole thing is true. So you were born wealthy and you're a brain surgeon? Yep, definitely true. You've got money. You were born wealthy, you don't really make a lot yourself, doesn't matter. You're living off that family money. You were born poor, but you're an NFL player. Yep, you have money. You're doing great. You were born poor and you did not make any yourself. I'm very sorry, you do not have money, right? That's our only false conditional in these or statements. And then we could just run like one example of a not. So all a not does is just take whatever value you originally passed into it, and we are going to flip it. So if A was originally true, it is now false. And actually, I'm just going to go ahead and clear everything. And I'll just clear all of these out as well. So A was true, but I asked for not A. I get false. Okay, so those are all of our Boolean statements. Now we're going to talk about conditionals. And there are three different ways that we can write our if statements in Python that we will talk about in this class. So a conditional statement is one that does not always run. It only runs if a certain condition is true. So when I have a conditional, I'm going to have some sort of test, and the computer evaluates that test. And then if it is true, then it will go ahead and enter into that branch and run whatever code we give it. So in this example, we have just an if and nothing else. So an if statement all by itself is a standalone statement. If it is true, the computer will go ahead and do those instructions. If it is false, it does nothing. It just moves on to the next line of code. So here I have created some variable called raining, and I just put a false inside of it, so not raining. So the question is, if, so here's kind of our syntax. We use the reserved word if, And then we're going to give it some kind of test. Is this true or false? And then you'll notice that we kind of have this indentation. In Python, the way that you tell the computer that something is part of the conditional is that you tab it over, you indent it over. So if it is raining, then you should grab an umbrella. But if it's not raining, we don't need to do anything. So just move on with your life, right? We don't have to do anything if it's not raining. So we don't need any other branches or any other checks. The next conditional statement is an if else statement. And this one is kind of like a fork in the road. You have to do one of these two options. Like one of these two things will run. So there is no, we just ignore it if it's false. In this case, if the conditional is false, then we're going to run down here and we're going to enter into the else branch. Now, you might notice that we have a conditional here, we have a test here in our if heading, but there is not a conditional down here, right? We don't have another statement. Like you don't say, let's run through and see this example. It says, I'm asking for user input, enter a number. I read in their answer and I cast it as an int so I can do math with it. So, okay, I have the user's answer and their answer is stored inside of X. And here's what I want to know. Is the number that they entered even or odd? And that is a fork in the road question because all numbers are either even or odd, all of them, including zero. Zero is even. So there are only two possible options here. So I could say if, and then here is my check. How could I tell if a number is even? If the number is evenly divisible by 2. So we have an operator that says that, right? We have an operator that says, I want you to divide by 2 and then tell me the remainder. If you divide by 2 and the remainder is 0, then it was evenly divisible by 2. This is an even number. So if, remember that modulus operator, that percent sign is a modulus operator and it says divide and return the remainder. If you divide a number by 2 and the remainder equals 0. See how we have the two equal signs? This is a relational operator. It's checking for equality. If this number equals 0, then what do I want you to do? Print even. If this conditional is false, so if they enter the number 7, and 7 mod 2 is 1, it will say, does 1 equal 0? No, this is false. So what it does is it comes down here to the else branch. So there's not another conditional down here that says, x mod 2 does not equal 0. We don't need that. There's one single test with two possible options. If it's true, then I run my true branch. And if it's false, then I come down here and I'm going to run this else branch for false. So let's just kind of test that out. Like, let's just write some code and just kind of see that. So I'm going to escape out of, there we go. I was trying to escape out of it and I couldn't quite get it to click out. So let's just come over here and run just like a basic little if else. So we say enter a number and then the user can enter any number they want. So I'm going to enter the number 9, which is my favorite number. And the computer says, here, let's just clear that out. And the computer says, what is 9 mod 2? 1. Does 1 equal 0? No. Come down here to the else branch, print odd. And that's what we see because 9 is an odd number. I could clear this out. I could run the exact same program and I could enter in an even number like the number 8. And this time, because this conditional was true, it came into this branch. So it prints out even. Great. Well, not every, possible option is going to be either just like a true false, like a fork in the road option, right? Like sometimes we need the computer to be able to make decisions, and there are multiple paths that we potentially want it to be able to do, right? You can think of an if else as kind of like a true false question on a test. There's only two possible answers, true or false. An if elif else statement is going to be kind of more like a multiple choice question. There are lots of different options, but we are only going to run one. We're only going to go through and do one branch. So the computer will start at the top and it will check them one at a time. And then as soon as it finds the first match, it will break out of the entire code chunk. If it checks every conditional and none of them match, then it will run the else statement. So the else statement is kind of like our default, you checked everything and nothing, turned on, nothing kind of was true. So we're going to come down here and run the else statement. And you can have as many elif options as you need. So if you have ever programmed before, you are probably used to this command being else if. Python just shortened that and just kind of combined the words into one and just, kind of made it a little shorthand. So elif is saying else if. So let's see this option. Here we want to go through and take the number that the user passed into us, and I want to know if the number is positive, negative, or 0. So this time we have 3 possible options. I cannot use just an if else for that, right? If else would only be 2 options. And here I have 3 options. So I tell the user, enter a number. I read in their answer. I save it as an int so that I can do math with it. And I put their answer inside of X. So the computer starts right up here at the top. If your number is less than 0, it's negative. If that's not true, like if that comes back false, then it's going to come down here and check this one. So now we have another conditional. There's something else I want you to try. Else if, so here we're going to call that command elif, your number is greater than 0, then that number is positive. If you checked this and it was false, and if you checked this and it was false, then the only other option is that the number equaled 0. So that is my else branch. That is my any other option. It must just be 0. Okay. So I'm going to clear this, and I'm going to clear my output. And I'm going to just take a look. So I'm just inserting this from that toolbox. So here in my conditionals, I have an if else, and an if elif else, all 3 kind of possible statements. So here is an example with multiple branches. So here we're asking the user to enter in like a grade 0 through 100. And then we're going to determine whether or not their grade was an A, B, C, or something else. And we didn't really differentiate between D or F, but we could. So here's what this says. If score is greater than or equal to 90, and once again, CodeMirror kind of has a little bit of funky syntax for that, but what we're really saying is less than or equal to, then that is an A, right? If your grade is a 90 or above, then you made an A. Else if you made an 80 or above, then that would be a B. Else if you made a 70 or above, that would be a C. And if all of those things are false, then we're going to come down here and run our else branch. So let's say that I told the computer that I had, let's say I have an 84. It's a great grade. It starts here. Is 84 greater than 90? No, it is not. Is 84 greater than 80? Yes, it is. So it does this one statement. And even though this is also true, right? 84 is greater than 70, but I'm not going to print out C because all of these things are chained together. All of this is really like one big code chunk. These are all different possible branches for just one code statement. So as long as I find as long as I find one that is true, I'm going to enter that path. I'm going to run that option, and then I'm going to break out of the entire code chunk. We can have conditionals inside of other conditionals. And we call that nesting. So a conditional inside of a conditional would be like nested inside of it. Kind of like those Russian nesting dolls where you have like a little doll inside of a bigger doll, inside of a bigger doll. All right, we can just kind of keep going. So the way that you tell Python where, if a conditional is part of another one, we just tab over again. So let's take a look. Here, I'm going to go through and kind of like trace this code. So I'm going to just go through and read the code manually by hand and just try to predict what would the output be if I gave it different starting values for these Booleans. So here I have two Booleans. So the question is, are you hungry? Yes or no? Because that is a yes or no question, we can store it as a true false value. So this is a bool. And my next question is, do you have money? Yes or no? Because the answer to those two questions are what's going to go through and decide, what we need to do with our time. So the first question is, if you are hungry. If this is true, then we're going to go in and run this entire, like everything that's been tabbed over here. This whole entire thing is part of the branch that we enter if we are hungry. So if we are hungry, the next question is, do you have money? If this is true, then go eat out. If this is false, then we come down to this else branch. We need to eat at home. If hungry was false right off the bat, if someone says, are you hungry? And I say no, then it doesn't matter. Like, I'm not trying to figure out where I'm going to go eat. I'm not hungry. If hungry was false right off the bat, we're going to drop down here to this else statement. We'll go take a nap. Okay. And then this is our last slide. Okay. So what we want to go through and do is run a little example of this because your programming assignment. So this week we have our second programming assignment. And I'm going to pull up the instructions. So here we have Python conditionals and we have Python program 2. And here are the instructions. You are going to write a recommender program that is going to ask the user 2 questions, and then you're going to give them some options based on their input, and then you're going to make a recommendation based on their answers. So you can make recommendations for anything that you want. So like what movie should or what restaurant should you eat at? What movie should you watch? What book should you read? Where should you go on vacation? Where should you go to college? Like whatever. What job should you have when you graduate? Like you can go through and try to recommend anything of your choice, but the answer choices, like what you recommend, has to be based on the answers to their questions. So the way we're going to do that is we will print out different answers based on, I ask you a question, I read in your answer, and then if you answered one thing, I'm going to do these options. Else, if you answered a different way, I'm going to do these options. We have to go through and use conditionals to make this input based on, or to make our responses based on the user's input. So here is an example. What type of vacation do you like? And I have to tell the user exactly what I want them to type in for their result. A mountain, a beach, or a city. And I like to go to the beach. And then I have a new question. What is your budget? Cheap, moderate, or expensive? And I have no money, right? I'm a college student. So what is a cheap beach vacation? For a cheap beach vacation, drive to Corpus Christi. Perfect. You must give a minimum of 3 options per question. So there will be a 9 possible endings, right? So there are 3 options, and that's for each choice. So 9 combinations that I could go through and put for all of them. Okay. You either need to use logical operators. So you could go through and like ask these questions separately and then use those and statements, right? Did you enter beach and cheap? Well, then here's my recommendation. Did you enter beach and moderate? Well, then like drive to Destin or, something like that. Or you can use nesting. You could put this question inside of the first question. So the only way to get there would be if they answered a certain way to the first question. So I'm not 100% sure how much sense that makes if I just sort of just verbally say that. What I think would be much more helpful is if we actually go through and see an example of that. So I'm going to go through and just program a little example. So this is going to be a short example of nested conditionals. And the example that I'm going to write is going to be a short choose your own adventure story. So, a choose your own adventure story is one where you have a little story and you ask the user, what do they want to do based on what's happening in the story? And then something different happens based on their result. So, I'm going to do just a very simple one. I'm only going to have 2 questions and I'm only going to have 2 options. Remember, for your program, you are going to have to go through and have 3 options. So your program will be a little bit bigger than mine, but this is still a good exam. Okay. So the first thing I want to do is just print out a little something for my story. So I'm going to say, you are going camping and you hear a loud bang outside your tent. Okay. So I just have a little setup. I just have a little story. And then I want to get the user's input. I want them to answer the question. So if you remember the way that input works, we have the command input. And then inside the parentheses is where I kind of put the prompt. So this is what will get printed out to the screen. So here's where I want to ask a question. So if you are camping and you hear a loud bang, what are you going to do? So enter, stay, or investigate. So we have two possible options. You're camping and you hear a loud noise outside. Do you stay in your tent or do you go try to check it out? So input is going to read in their answer and save it inside of some variable. So I'm just going to call my variable choice one. I could have named it anything. I could have named it whatever, I wanted, but because this is the first question that I'm asking the user, this is going to be like the answer to their first choice here. Okay. So I have two options. I could say if whatever is inside of choice one, so that's going to have their answer saved inside of it. So if whatever the user entered in the computer is equal to two equal signs to check equality, if it is equal to the word stay, then what do I want to do? And you'll notice that this code mirror kind of editor automatically indents over for us because it knows that when I write an if statement, my next line of code needs to be indented. And then it's kind of going to stay over there indented until I choose to backspace it and write some more code back over there on the far left. And sometimes that's nice and helpful, and sometimes it gets in your way. Sometimes it's kind of annoying. So it depends on if you want it indented or not. So what do I want to happen if you hear loud noises outside and you choose to stay inside of your tent? Okay. So what's going to happen is it was loud thunder. It is pouring rain outside. Okay. And I'm going to give the user another choice. I'm going to ask them a second question. So this is going to be my second question. And I want this question to be nested inside of my stay path. Okay. So here's my second question. So I'll say choice two. So you hear that it's raining outside, like you're in your tent, it's pouring rain. Are you gonna stay in your tent in the rain, or do you try to maybe like go get in your car or kind of double check something? So I have kind of like a place where I'm going with this. So I'm going to say, do you check the tent stakes? So that's just kind of a yes or no question. And the reason that I'm going to ask the user that is because this whole kind of little story is just going to be based on the worst camping experience that I ever had in my life. I was a young kid, and apparently we had not, the adults had not put together this tent correctly, and the stakes were not in the ground right. And it just kind of was, I guess, maybe just barely put together. And so a thunderstorm came and the stakes washed away and the tent, was messed up and it kind of flooded, like the ground kind of flooded. And we woke up in the lake. Like we were on our little air mattresses, literally floating in the lake. So it was awful. So here's going to be my question. If you are camping and there's a big thunderstorm, what are you going to go do? So if the user says yes, which again, that is a string and strings go in quotation marks. So if the user says yes, here's my first little ending. Um, uh, you fixed the stakes and saved the tent. Yay. Okay, great. But what if we entered no? So see how this time I don't want this to be here inside of my true path anymore. So I had to kind of back up because indentation is how Python knows what is part of which branch. So I kind of have to come right back up here. So this if is lined up and with this else. And now what do I want to say if they said no? So if they said no, if they do not go check the stakes, then we're going to say the tent washed away in the storm. So sad face. Okay, so here we have two endings, but all of this only happens if the user decides to stay inside of the tent, right? Because this is indented over, the only way I get here is if they chose to stay and also they said yes, they would go check on the pouring rain outside, right? So for this next one, I need to back up all the way back because now I want to come up here and and I did one too far. There we go. Because I want this branch to be lined up with that very first if. So we could either just write this as an else branch, which is kind of like what I did previously. And see, I don't like that it auto indented there. But my other option is I could make it an else if. Because, come up here and take a look at this really quickly. If somebody typed the exact literal word yes, then this will be true and it will work how we want it and it will run into this branch and it will give us the correct answer. But what if they entered the word yeah? Or what if they said yes, all capital? Or what if they said yes with just a capital Y? Or, what if they said check instead of yes or something like that? Even if they intended to go into this branch, anything other than a perfect match with this string would evaluate to false and we would go into the else branch. So, if somebody said yeah instead of yes, they are going to get the story ending as if they had said no. So that's one thing, like I'm going to come up here and say Aleph, and I really dislike that it is forcing that over there, so I will back it up myself. So I say Aleph, and I specifically want to check to see, did they say investigate? So here's my second branch. So you're camping and you hear a loud bang, and so you chose to investigate it. So you went outside to look at it. So we will say, wow, someone is setting off fireworks. So pretty. Okay, great. And then I'm going to give them another question. So I've got to kind of set up something for them to have a question so I can have my other two endings. So I'm going to say something is moving in the bushes. Do you check it out? Okay. So now I need to read in their answer. So this will be my kind of choice two branch for this path. So like if they choose to investigate, then I need to have my choice two. So I will read in their input. And that should be right here, right? This is already my question. So I already have my prompt. Do you check it out? Yes or no? So instead of printing that, I actually want to get the user input. and we will save that inside of choice 2. Remember that when we were using these input statements previously, it reads in the answer as a string. And so when we were trying to read in numbers and do math with it, we had to go in and force, our input command, we had to cast it to be ints. In this case, we want strings. In this case, we are reading in words. Stay, investigate, yes, no, check, whatever. Those are strings. So we go ahead and just leave it as the string value. And then because I am working with strings, I'm going to just have quotation marks around those strings that I want the computer to go through and check when it's checking to see if this value equals this value over here. So, okay, so the question is, something is moving in the bushes. Do you check it out, yes or no? So we have if it is true. My son is over here saying no off camera. So if choice 2 equals, so we'll start with the yes branch. So yes, you go see what's in the bushes. And once again, this is based on the same camping trip where my brother-in-law was taking a nap in like some little lounge chair things at this campsite, like kind of around the fireplace or whatever. And something was moving in the bushes, and he went to go see what it was, and it was a skunk. And it sprayed him, and he stunk the whole rest of the trip. Tried to wash it off, not happening. It was just, it was rough. It was a rough time. So if they say yes and they go investigate it, it was a skunk and he sprayed you. Sad. It's a rough time. Okay, and then my other option, so I'm going to say else. So if they said no, so we'll let this kind of be our happy ending. So we will just say you let it be and enjoy the fireworks. Great. Okay. So we could go through and run this program, and we're going to get different answers and different kind of a different story with a different ending based on what we say. So are we going to stay or investigate? Let's stay. And do we check the tent stakes? And honestly, if it was raining outside and I had never had this experience, then no, I would just probably stay inside. So you are going camping and you hear a loud bang outside your tent. So see, we chose to stay. Oh no, that's just the very first thing. And then we chose to stay. So we got this next. It was loud thunder. It is pouring rain outside. And we answered no. So it entered the else branch. The tent washed away in the storm. Sad. When you are going through and nesting conditionals like this in your story, it's kind of easy to get lost. Like it's easy to go through and kind of forget like what branch is this part of, where am I working right now? So this is where I would say good comments and having like good documentation is really very important. So, I would go through and make a comment, what is this? What is this branch? What is this path? And I would come down here and kind of make a comment for like the beginning of this one. What is this branch? What is this path? One thing that I have. So if you're using Glide, you can do this, but it's not available in most editors. This is just something that I have added to this environment, is I made it where you can go through and highlight the chunk of code that you are in. So if you come up here to this heading, so here, this is an if heading. So I have my reserved word if, and I have my conditional, and I have my colon to end it. So if I come up here and I right click, this is going to highlight everything that is part of choice 1 equals stay. So you can see that it does include this other if else statement. And so just kind of having that little highlighting just helps you visualize and just see very clearly all of these things are part of the stay branch. And then you can come up here and right click again to remove the highlighting if you want it to go away. So same thing, I could come down here to this option. I could right click here. Everything that you see highlighted right now is going to be part of that investigate path. So all of these print statements, getting the second choice input, having another conditional for my endings, that's all going to be part of investigate. And, we could go in and check even like these smaller ones, but really I think those are probably kind of easier to tell because I only have like one line attached to them. Really, where I think it can start getting confusing is when you have a lot of code in one branch, and especially when you have other conditionals nested inside of parent ones. So just kind of know that that is a little hint that you can do. You can right click on the heading and right click again to remove it. And I do also, whenever we get to some of these other, so if I come up here and click, when we get to some of these other statements that have, loops or something else in them as well, you can also click and highlight those. They will show up a different color. And our function code box will also show up a different color. So, okay, that is all that I have for the second week of Python here. So we have gone through Boolean statements, logical operators, we've gone through conditionals, and we've gone through nesting. There is also a quiz this week over Python conditionals. So if I come in here and take a look at that quiz, what I would like for you to know is an if statement, if else, if else. If I give you like some code, can you tell what is part of that block based on how it has been indented over? Know how and or logical operators work. And then the relational operators are equal to, not equal to, less than, greater than, some of those kind of numerical comparisons. So that is it. I hope you have a great rest of your week. Please email me if you have questions. I would be so happy to meet with you, help you study for the quiz, help you write your program. Just kind of sit down and practice and answer questions that you might have. I'll see you next week.